parents' monument. I put a lot of representations on here of what was important to them. I have our home located on West Park Street and a representation on the right of my grandfather's coal mine. My desire to stay here is so strong is because of my strong family ties here. I just have strong roots here, and it's home. It's always been home to me.
John's hometown has now become an open laboratory for scientists. Geologist Glenn Stracker from East Georgia College and his field associate Melissa Noelter have tracked these fires for many years.
We're looking at the carbon dioxide concentration and the carbon monoxide concentration of the coal-fire gas.
Oh, look at this. Look at this
wow.
vent right here, the carbon dioxide concentration. Look at how fast that's climbing.
Wow.
That's incredibly high carbon dioxide concentration.
Oh my God, that was one.
And they talk about global warming and greenhouse gases. This might actually go right off the scale of this tube right here.
Get out of town.
Yeah.
I think that's the highest one we've had here
That's
ever.
the highest one I've ever gotten. Look at that.
It's telling us from this blue color here that the concentration of carbon dioxide in this coal-fire gas is quite high. It's 1.5 volume percent. In the case of the carbon monoxide, we have a concentration of carbon monoxide, which is a toxic gas, of approximately 50 parts per million. Now, according to the U.S. Environmental Protection Agency, 35 parts per million ingested in an 8-hour period is toxic. And this is 50 parts per million just in a few seconds. Carbon dioxide and carbon monoxide are an indication of subsurface burning, which is in fact happening. So this fire is active and it's alive. And these two gases, of course, are pollutants and are contributing to the pollution here in the Centralia area, and the gases will move off into the atmosphere and contribute to atmospheric pollutants and move into other areas as well.
Exposure to these gases for a prolonged period can lead to carbon monoxide poisoning and respiratory illnesses like bronchitis and tuberculosis. It can even cause stroke and heart diseases. Although the fire is still alive and raging, residents from nearby towns continue to dump their garbage here. The Pennsylvania Department of Environmental Protection is responsible for monitoring the fire's progress. The fire is consuming a 13-kilometer seam, progressing at the rate of around 36 meters on each end per year. But there are no plans to extinguish the blaze. The department feels it poses no immediate threat to neighboring towns.
Once a fire begins in a particular area, one of the first things to do is look at the potential areas to which that fire may spread. And once you know the potential areas to which that fire may spread, to come up with a plan of strategy for preventing it from spreading outside that area. If you can contain it to a particular area, then you have a much greater chance of actually extinguishing that fire.
Looking at this lush green landscape, it's difficult to believe that once there was a raging fire beneath all this. Jokta was one of the most fierce fires of Jharia coalfield. K.K. Malhotra, a BCCL employee at that time, and his team brought this fire under control.
Blanketing with sand had failed completely, and flooding with water also failed, and finally it was decided that laying out the 3 blankets for dealing with this fire was the only technically and financially acceptable solution.
Multiple blanketing is a method in which the area of the fire is first leveled by giant earth movers. Then, layers of soil and overburdened material are laid to cut off the supply of air, thus breaking the fire triangle. After reclaiming the charred landscape of Jogta, firefighters greened the entire area to prevent future erosion. At Jogta, they even built a 3.5-meter deep fish pond with live fish in it. Sitting on top of an underground fire, it's one of a kind. Jogta is a success story, but despite such path-breaking attempts, Jharia still has 66 coal mine fires, and many of them are in active mines.
Steam is coming out of this borehole, which means that the temperature is still very high.
In a recent fire accident in West Jharia, around 53 miners were trapped inside a mine. It's likely that methane gas accumulated in the mine and exploded. After 2 whole days, the rescue workers brought out 50 bodies. All of them covered with coal dust and burned so badly they couldn't be recognized. The same killers that are released into the air every day by these coal mine fires. Active mines may have up to 40 coal seams or layers. Several layers are mined simultaneously. Each site generally has at least 200 workers at any given point. A close watch on anything unusual is part of all responsible mining exercise. Today, these miners have noticed an unnatural concentration of gases coming from a mine shaft. A major disaster is waiting to happen. The lives of 800 miners are at stake. Firefighters have a complicated task ahead of them. Besides evacuating the miners, they have to prevent fire and fumes from spreading to other parts of the mine. They decide on a strategy. Isolate the fire within the mine. Build a barrier.
So our main objective is to do the isolation stopping and isolate.
This brick and concrete wall should block air from getting to the fire inside the affected mine tunnel. Without oxygen, the fire can't survive for very long. This process is called isolation stopping. Firefighters leave a few openings to take gas samples at regular intervals. This helps them to check whether the fire is burning out.
Just construction of toppings may not.
Isolation stopping may not be sufficient, especially when there are surface constraints like villages or rivers. Then we may need to inject coolants into the fire.
Liquid nitrogen looks like shaving foam. This powerful coolant attacks the third element of the fire triangle, the heat. Liquid nitrogen is generated in a plant and transported to the fire through long pipes. Firefighters have managed to reduce the heat and isolate the fire. mine and miners are safe for now. But fighting fires as and when they erupt is just a temporary solution. To limit their spread, one needs to understand how these fires behave. That's what German scientists are trying to find out in Munich. The German Remote Sensing Data Center, DLR, is located in Wesseling near Munich. Scientists are using the latest satellite technology to track coal mine fires 6,000 kilometers away in China. The German satellite BIRD is a special remote sensing satellite fitted with a thermal sensor to detect temperature variations over the Earth. The satellite detects surface heat released by burning coal mines. Combined with data about the actual coal deposits, scientists can project the size of the underground fires. BIRD has already detected several unknown coal mine fires in remote areas of China.
This fire area here seems to be...
Once hot spots are located, scientists need to predict how the fire will behave. To do this, they make an animated fire model.
Hi Stefan, hi Manfred.
Hello. Hello. Stefan has new results from satellite images.
Yes, maybe I can show you the situation here. This hotspot over there seems to have spread into two hotspots and moved further to the east. So the question is, what can you do from your modeling side?
We could do a two-dimensional setup here for the situation.
It's not easy to make fire models.
Hello, Lydia. I have here two stones from Buda.
Rock and coal samples from the site are tested for their reaction to heat and fire. Scientists also need to calculate the amount of gases being released at the site and the chemical content of these gases. They've installed automatic gas analyzers at the site. Once all this data is fed into the computer, the fire model is almost ready. It's a 2D representation of the actual fire. From the surface, oxygen in blue is finding its way underground. It's fueling the fire, as shown by the expanding hotspot in the center. The fire model works like an early warning system. It helps scientists to predict the path and the speed of the fire and to take measures to prevent its spread. But this technology is just at the testing stage. It may help mine firefighters worldwide, but will it be enough? Or will it be too little, too late? Firefighters at the Jharia coalfields are worried. Gases are poisoning the whole area. In some parts of Jharia's coalfields, 80% to 85% of the residents suffer from one or more forms of respiratory problems.
All right, now I'm going to stick this right down.
Glenn and Melissa are worried too. Surface temperatures here are as high as 84 degrees centigrade. Combined with toxic gases, Centralia is going from bad to worse. A major pollutant released by coal mine fires is carbon dioxide, a greenhouse gas. Within the last 200 years, carbon dioxide levels in the atmosphere have gone up by 25%. This has contributed to a rise in the Earth's temperature, leading to global warming. According to rough estimates, coal mine fires worldwide may release as much carbon dioxide as 50 million cars. That's as much as 37% of cars in America. Mine fires are not just a problem for countries in which they occur. These fires are truly a global issue and need to be tackled on a global scale.
I think what needs to be done is we need to look at mine fires around the world that have occurred under certain different set of circumstances and look at the ways those mine fires have been approached, how they've been extinguished, and see what's worked the best, and possibly think about using those for various kinds of fires when they do occur.
Science has offered some hope, but a comprehensive solution is far from sight. But those on the front line refuse to acknowledge defeat.
I don't know if I ever could leave Centralia. I mean, if the government ever forced the issue, which technically, legally they could since they own the houses and the ground, that might be the only way. As far as leaving voluntarily, I don't know if I ever could. I truthfully don't know if I could.